Okay, so I'm back again. I'm still trying to diagnose this problem that I'm having where this 47 comes up on my output display during the third micro instruction during the add cycle. And that's the only time it seems to happen. Now, in looking through this problem, I took a look at the 74LS273. In pin 11 is the clock pulse pin. And the way that this is wired, I'll have to take a picture and superimpose a close-up of what's going on down there. But the way that's wired is that we have the AND gate sitting in front of the 74LS273, and we have that clock signal coming in to the AND gate along with the OI signal also coming into the AND gate. So those are its two inputs, and then its output is going across to that 74LS273. So you can see here I've got the oscilloscope hooked up, and earlier I was testing the input onto that 74LS273 right there where that clock pulse is coming in at, and I've been noticing that on the oscilloscope I'm definitely getting a solid logical high when I see that 47 come up on the output display. It's coming in at about 3¼ volts. So now I'm backing up the probe to the OI signal, and I want to see, I haven't actually tested this yet, but my assumption is that that OI signal must be sending a pulse to the AND gate along with the clock pulse, obviously, because otherwise there's no reason whatsoever why that AND gate should be outputting a logical high on its output. So I'm going to go ahead and test that. So I'm going to reset the breadboard computer using the handy dandy reset switch that Ben did a video about yesterday. And so the first instruction is the load LDA, and I've not had a problem with that, so I'm going to go ahead and step through those 5 micro instructions quickly. Oh, by the way, I added this blue piece of gel paper over top the output display, so I hope that is working better now, not light bleeding so bad. So here's the 5 micro instructions. Right now we're on T0, so that's T1, T2, T3, T4, and now when I press the button again, we're back around to T0, but now we're on the add cycle. So let's pulse the clock one more time here. So now we're on T1. Now it's the next instruction that causes that 47 to come up on the output display. And what I expect to see is that blip on the oscilloscope back there showing that we're getting a logical high on the output in the OI signal coming off, all of our control signals. And we really shouldn't be, because the EEPROMs are not programmed to give us a 1 during this time. But let's and as we've seen, it doesn't always happen. So let's go ahead and pulse the clock and see what happens. Yeah, so there I pulse the clock, and you can see the 47 comes up, and very clearly back there on the oscilloscope you can see we're getting a very definite logical high. Each one of those vertical cells is 1 volt, so we're actually not only getting a signal there, but we're kind of getting a bounce, it looks like. So it bounces about to 1.5 volts, it looks to me, and then comes back down, and then shoots back up to 1, 2, 3, it looks about 3¼ before dropping back down, and oddly it seems to be coming back down below 0 before stabilizing. So yeah, clearly that OI is pulsing and the clock is pulsing at the same time. So now I know why the 47 is coming to the output display, but I still don't know. I mean, I guess I know what's causing it, but I still can't quite comprehend why it's happening. And I can't comprehend why it's happening intermittently, as we saw in the video that I posted last night. And actually, I'll test that right now as well. I'm going to reset the breadboard computer and then let the clock run a couple of times to see what happens. And I'll reset the oscilloscope each time. So reset the breadboard computer. I'm going to not turn the clock on just yet. I'm going to put the oscilloscope back in run mode, single step, and now I'll turn the clock on. And you can see, it completed the whole cycle, and back there on the oscilloscope, again, we very clearly got a logical high, and this time we got 1, 2, 3, 4 volts, and I can see it's peaking at the top, so it's even above 4 volts. So let's reset this and see what we get. I'm not going to reset the breadboard computer yet because the clock is still running. So I'll turn this back to run, single step. Now I'll reset the breadboard computer. And again, same thing. Now that's actually what I was hoping to see. Now you notice that time we didn't get the 47. I mean, yeah,